G'day viewers, welcome to this session, Hardening Windows Server. My name's Orin Thomas. I'm a Principal Cloud Operations Advocate at Microsoft, and you can get in contact with me at orin.thomas@microsoft.com or follow me on Twitter at OrinThomas. So in this session, we're going to be talking about hardening Windows Server. But before I get too far in, let me give you a couple of caveats. There is no perfect security solution. So you can follow all the advice I'm going to give you and all the stuff I'm going to link to, and it's still possible that you might get attacked. What hardening your systems is going to do is it's going to block the chance that casual attackers are going to be able to penetrate your system. If you are being attacked by a nation state or an insanely competent attacker, say someone from the future has come back in time to hack your server, you're probably stuffed. But what we're talking about here is going through and systematically doing your best with the resources that you've got. And I want you to think of it this way. I want you to think of it as server hardening being a journey, that you are trying to improve your security posture, but you're never going to get it perfect. After you've listened to this session, one of the things I do want you to do is go out and do some research on important security baselines. Now, Microsoft does publish some general baselines as part of the Security Configuration Toolkit. There are also third-party organizations, usually government-associated, but some industry bodies, that generate and publish their own baselines. When you're looking at these baselines, what they are doing is they're talking about all of the stuff that you can turn on. For example, there is the detailed low-level guidelines available from NIST.gov, which is the National Institute of Standards and Technology. There's also the Centre for Internet Security, and the Centre for Internet Security does revisions of baselines across a wide variety of topics, including various Linux distributions, obviously Windows Server. They haven't published a baseline yet for Windows Server 2019. They also do product-specific baselines, so you'll find baselines in there for SQL Server, for Internet Information Services, and they also do baselines for cloud. And what those are a bunch of security recommendations that you can go and implement for yourself that will tighten the security of a particular deployment. You've also got the IASE Windows Server 2016, which is the Defense Information Systems Agency Security Technical Implementation Guide, which is also called a STIG. Again, you can go and download that from the link that I've got listed here in the slide. So, in terms of how do you harden? Well, one of the easy things that you can do is you can use group policy templates, and Microsoft publishes some, and some third parties go and publish some. You've also got people like the link here for luke.geek.nz, where he has gone and taken the IASE GPO. Remember, I was talking about one of those being a baselines, and shows how you can use a desired state configuration template to go and apply that template all at once to a system. There are some challenges around hardening server. And the big one is that if you harden your servers too much, things can or may or will stop working. So what do I mean by that? Well, here's an easy example, and I'll come back to this as I go through the talk. If you think about SMB1, SMB1 is something that we know that we need to disable. Now, a lot of organizations haven't been able to disable it because they're still relying on that protocol because they've got older systems that they need to interact with. So you can have the most secure system in the world, or as tight as you can make it, but do realize that that may come at a cost of interoperability. Now, also, come in and harden things in a manner that's commensurate with your organization's risk profile. So how you would harden the systems of a financial organization is going to be very different from how you would harden the systems of the local scout troop. Also, as I have already intimated, harden incrementally. Tighten, test. Tighten, rather than starting with a fully hardened configuration and then trying to figure out why certain things don't work. If you're going through this incremental process, you go, oh, I just put that setting on, and then suddenly all of this other stuff doesn't work. So that you can roll that one setting back instead of going, well, I've just turned on 500 security settings, and now I've got to figure out which one of these 500s is actually causing the problem. Okay, so what are you trying to avoid? Well, there's a couple of different things. Obviously, you've heard of pwning a server. One of the other things that you want to avoid is a thing called domain dominance. And that's the ultimate aim of attackers in Windows networks. Basically, what an attacker wants to do on a Windows-based network is own a DC. And if you own a DC, you have access to every system on the network. Why? Because that DC is basically your master authority of identity. When you are looking at your servers, when you are thinking about, oh my gosh, I think we've been attacked, remember that most attackers will leave certain traces of their activity. Make sure that event logs are turned on. Event logs will only record what you turn them on to record. And configure event logs to record everything. Now, in the past, you probably wouldn't do that because you were sitting there going, why do I want to have everything recorded? That's just going to take a lot of disk space. Well, these days, storage is cheap. And you've got machine learning to go and find the needles in these very, very large haystacks. The other thing you need to do is make sure that you go in and you ensure that your event logs are not configured to overwrite everything automatically. Now, what are you looking for generally if you're worried about being breached? Well, is there unusual privileged account activity? Is a domain admin account, for example, signing on at 3 a.m. If you've got that logged, you can go back and look at that and go, that's weird. Are there newly created user accounts on your server, in your domain? Again, an attacker will go and create a bunch of accounts. They might go and create a bunch of group accounts. Has the membership of privileged groups changed? Why is there a particular service account in a privileged group? You know, if you're an attacker, you might want to try and hide your activity by making something look a little more innocuous than it is. Is there a task or process running on your system that you don't recognize? Check your scheduled tasks. Is there something new, something unusual there? And scheduled tasks are often a method used by attackers to ensure persistence of their attack across system restarts. What to look for generally involves having, for example, if you notice that there's unusual network traffic to an external host. If you've got a computer that's suddenly communicating to a server in Ukraine or in Iceland or in Botswana, and you've got no reason that your server would be communicating with those countries, well, you could probably be reasonably sure that something's going wrong. You do, of course, have to know what normal looks like, which would mean that you need to know, generally we don't go and communicate with a server in Botswana or in Ukraine. Where should you look for unusual activity? Well, go and look in your standard event logs. You know how to find those. Go and look in product-specific event logs. A lot of those are kept in the same place as the standard event logs now, but some products keep their event logs in the product directory. Turn on firewall logging. Look in your firewall logs. Have a look in your file system. Sometimes there's unusual files sitting in plain sight. Why? Because who actually digs into the System32 directory and actually has a look at all of the applications that exist in that directory? Now, generally an attacker shouldn't be able to get anything in there, but maybe they did. Is there unusual things in the registry? Have a look at Task Manager. Have a look at Resource Monitor. Is there unusual activity that appears there? The other thing you'll need to do is you need to minimize the chance that your event logs themselves can be compromised. Simply because a competent attacker, when they're compromised your system, one of the first things they'll go and do is try to remove evidence of their activity. They'll clear their logs. So if you forward event logs to another server or to a central location or even up into Azure, then you have got them off the server and it's harder to remove that proof that someone's actually attacking your system. You can also create your own free investigation tools. One of the ones I recommend to people who maybe aren't at the stage of wanting to go out and purchase a third-party tool, or one that's really interesting for people who just want to go and look at what information can actually be teased out of the built-in event logs using a free tool, is Jessica Payne's WEFLs. Now, that's the Windows Event Logging Forensic Logging Enhancement Services. And you can see the link here to blogs.technet.microsoft.com, or just use your favorite search engine to go and look for WEFLs and Jessica Payne. It's sitting in GitHub, and basically you download it. It's a bunch of scripts and a web interface, and it allows you to go and look for very specific forensic related events that'll be sitting in your event logs. In terms of protecting your overall Active Directory infrastructure, your domain controllers should always run the most recent version of Windows Server. Now that we're in January and Windows Server 2019 is pretty much GA, you should either have or be ready to migrate to Windows Server 2019. The most recent version of Windows Server is always the most secure. Your domain controllers should not be running a GUI. You should be running them in server core configuration. One of the simplest things that will stop, it'll stop someone signing onto your domain controller, opening a browser, and having some malware dropped on it. You should have, if possible, device and credential guard enabled on your domain controllers. Talk about those a little later. The domain controller should actually be blocked from directly communicating with hosts on the internet. So that means that your external firewall should actually be blocking your domain controller talking out to hosts on the internet. When it comes to updating them, well, you've got an internal WSUS server. And then admin sessions, say RDP, PowerShell, should only be known from specific administrative IP addresses, be they a privileged access workstation, which is a lockdown workstation, or a jump server. Your admin accounts, you should lock down all your admin accounts, so where and when they can be used. You restrict their logon times. You restrict their logon locations. You configure an account expiration policy and stagger these so that you don't lose all of your admin accounts at once. Also, ensure that your password policies are actually enforced on your admin account. You don't want to have an admin account that's got a single password that's never changed and it's a simple password that everybody knows. Consider using the protected users group. Now, this is a special group available in Server 2016 and Server 2019. Now, members that are placed in this security group aren't able to use cache credentials, so their credentials will not be stored on any system that they're logged onto. They've got to authenticate each time. They cannot use NTLM authentication, and they cannot use older cipher suites for Kerberos pre-authentication. What you should do is add all privileged accounts to this group to absolutely minimize the chance of cache credential harvesting using a tool such as Mimikatz. Consider using authentication policy silos. What an authentication policy silo does is it allows you to define a relationship between the user computer and managed servers accounts. Account can only belong to one authentication policy silo, and accounts in a policy silo are associated with a silo claim. Basically, you set it up so that only a particular silo claim has access to particular resources. You should disable NTLM. This is a big one. NTLM is an older authentication protocol. You can capture that traffic, you can decipher it, and it's much easier to compromise. Now, before turning it off, audit the use of it. Figure out what systems on your network are still using it. That'll mean that eventually you're going to have to get rid of those old 2003 servers that we know you still got. And then you go and configure the network security, restrict NTLM authentication in this domain policy. You configure that and you can see that in this particular slide. Use Credential Guard. Now, Credential Guard's a new technology built into Windows 10 and Windows Server 2016 and 2019. It uses virtualization-based security to protect cached account credentials against attacks such as pass-the-hash and pass-the-ticket attacks. Basically, it turns off unconstrained Kerberos delegation, NTLM version 1, MS-CHAP version 2, digest authentication, Cred SSP, and Kerberos DES encryption. Your requirements are that you need Windows 10 Enterprise, Server 2016 or Server 2019. It works on virtual and physical machines, but does require a virtual TPM and a Gen 2 VM if you're using it with virtual machines. It requires secure boot, Intel VTX or AMD V virtualization extensions, second layer address translation, and a TPM or a virtual TPM. Another one, if you are going hardcore with locking down your Active Directory environment, one of the things that you should consider doing is an enhanced security administration environment forest. So what you do is you actually set up a separate forest and configure a trust relationship, and the admin accounts for your production domain are actually kept, or production forest, in a completely separate forest. And that forest is in a one-way trusted relationship. So it means that if your production forest gets compromised, all of the accounts that are admin accounts are still sitting in a completely separate forest that production forest doesn't have a bidirectional trust relationship with. So you can't jump from the production forest into the admin forest. You can jump from the admin forest into the production forest. All admin accounts in production are standard user accounts in the admin forest, so they're just unprivileged accounts in the host account forest. If an admin account's compromised, it can't be used to compromise other accounts in the admin forest. Any accounts that have admin privileges that aren't hosted in the admin forest will simply be easily identifiable and suspect when you are actually investigating an incident. You should, of course, be aware of the principle of least privilege. That means assign minimum required rights to an account. If an account then is compromised, the attacker can only perform a limited set of tasks. What I am suggesting you do here is that you avoid having what I call a Swiss Army knife account. Don't have a single account that's got permissions to everything. You know, it can do Exchange admin, it can do SQL admin, it's got Active Directory administrative rights. Have accounts that are very specific for specific administrative tasks and switch to that account when you need to go and perform that task. That means should that account get compromised, the scope of what the attacker can do will be limited to what that account can do. Implement privileged access workstations and jump servers. So I mentioned this earlier about limiting administrative connections. Basically, what a privileged access workstation is a hyper-locked down workstation. So you don't use it to access the internet. It's blocked from accessing the internet. It's blocked from accessing email. Servers will only accept admin connection from privileged access workstations. Only specific people can log on to them. And it has complete application restriction policies so that only a specific list of authorized software can actually run on that privileged access workstation. What you say is, right, you can only admin a server from this particular box, and this box is locked down so tight so the administrator who, let's say someone sends an email to an administrator that's got a virus in it or a Trojan in it, and that administrator opens it, well, it's going to open on their personal machine, not on their privileged access workstation. And a jump server is basically a box that you connect to and then connect into another server from, and it works in the same way. It's a clean room environment from which to perform administration. Now, good admin habits. Your daily driver account, used to read email, generate your TPS reports, should be a standard user account. You should not be logging in every day to your systems using an account that's got admin privileges. What you should do is you should actually sign into another machine and then get your admin account and then use your admin account from there. But don't be using your daily driver account, and it certainly should not have local admin privileges on your daily driver machine. Consider using Just Enough administration. What Just Enough administration is role-based access control for Windows PowerShell remoting. You specifically configure endpoints so that a user only has a predefined set of PowerShell commandlets, parameters, and parameter values. Actions are then performed using a special machine local virtual account. For example, you could set up a GIA endpoint that would just have the DNS commandlets available and the parameters limited to specific DNS zones. Someone can connect to that endpoint using an unprivileged account, and it's on a list of allowed accounts. They connect, and when they connect, they've got admin privileges only using those commandlets, so they can only manipulate a specific DNS zone using a specific set of DNS commandlets. Now, Just Enough administration doesn't work for everything. It only really works where the problem and the solution are clearly defined. That is, you know what you want to allow someone to do. If you don't, well, you need to then have some sort of other administrative tools, but you would assign that to a higher level of support. It also only works with PowerShell sessions, which is going to limit people who don't really know their PowerShell. Now, Windows Admin Center going forward is probably the tool that you're going to use for remote administration. And what you want to get into is a habit of performing remote rather than local administration. So you'd connect to a Windows Admin Center server, and then that server would have the ability to go and connect to other servers that you needed to manage. Now, Windows Admin Center eventually will allow you to run everything as a console without a GUI. Windows Admin Center will eventually allow you to run everything without a GUI. Everything will be running server core. Even the box that hosts Windows Admin Center will run server core. You'll connect to it via a browser and you'll do everything that way. Existing admin tools are going to still be supported by Microsoft, but basically going forward, expect new admin functionality to be put in Windows Admin Center. So if you want to do something with the GUI going forward, don't expect Microsoft to build a Microsoft Management Console for you. Eventually, it will replicate all functionality of all existing remote server administration tools and Microsoft Management Consoles. Not anytime soon, but eventually. Privileged access management is another thing that you should think about implementing. Basically, it's also known as just-in-time administration. Basically, what you do is you request privileged access. And so think of it as a time-limited group membership. So if you want to perform a task, such as changing a user's password, instead of having an account that's got the password change right, you request access to that right, go through a process, and then for half an hour, you can go and change your user's password, and then you're reduced back to normal privileges. So we're moving away from a model where administrative rights are permanently assigned to an account towards one where administrative rights are assigned on a limited amount of time basis. Another thing that you should implement in your environment is Local Administrator Password Solution, or LAPS. You've probably heard of this. Basically, what it does is it's a free tool you can download from Microsoft's website that allows you to have unique local administrator passwords on each computer in your domain. LAPS will randomize and change local administrator passwords every 30 days. It stores local admin passwords and secrets within AD. You can configure who can retrieve those passwords, but the idea is if you have someone who needs to log on to a particular workstation or a particular server using a local admin account, they basically run the LAPS UI. They retrieve the admin password for that particular computer, then they can sign on locally onto that computer. And then they can trigger a password change so that that password is automatically reset. What it allows you to do is it allows you to block having a common local admin password across all the systems in your organization. As I've said before, make sure that you are running Server Core for Windows Server where appropriate. It requires fewer software updates and reboots. You can manage it using Windows Admin Center, and there is sconfig.cmd to perform your basic configuration tasks. Now, Server Core becomes even better in Server 2019 simply because it has the Server Core app compatibility functionality, which includes a set of binaries and packages from server with a GUI without adding all of the server with GUI experience. You'll also be able to run perfmon, Resource Monitor, Device Manager, MMC, PowerShell ISE, Failover Cluster Manager, procmon, and other sysinternals tools on Server Core in 2019. Make sure you've got BitLocker turned on. It provides boot environment protection, provides encrypted storage protection, and you can use MBAM to integrate BitLocker into Active Directory. Implement network isolation policies. When you implement a network isolation policy, you use IPsec policies to restrict which hosts are able to communicate with servers. For example, block a file server from communicating with any computer that is not a member of the domain. Block sensitive servers from communicating with hosts that don't have a computer certificate from a specific CA installed. So what you're doing is instead of saying, hey, if you've got an IP address on the same subnet, you can come and talk to me, use IPsec as an additional communication blocker to ensure that only authorized hosts can talk to one another. Make sure that you replace as many service accounts as possible with group managed service accounts. It's a special type of account that can be used for services. The advantage of this is Active Directory will manage your service account password, which means that you don't have to sit there and do what a lot of people do and either manually manage service account passwords or do the worst thing, which is keep the same service account password forever and use the same password across all systems in your organization. It does require Server 2012 or higher functional level. Virtual accounts are the local service account version of a domain-based group managed service account. So if you've got a local service account you've got to go and create a virtual account instead. Now, there's several technologies that are built into Windows Server 2019. If I'm going to give you one other bit of advice in this particular talk, it's that if you really want to harden your server infrastructure, upgrade it to the latest version of Windows Server. Person from Microsoft telling you that, what a surprise. Okay, so Windows Defender Exploit Guard, really cool technology, has exploit protection, attack surface reduction, network protection, and controlled folder access. Exploit protection blocks malicious files, scripts, lateral movement, and ransomware behavior. Attack surface reduction rules, it's like the old Emmet, except for it brings it straight into the operating system instead of something you download. You've got network protection, which will block apps from communicating with untrusted network locations, and controlled folder access basically mitigates ransomware. So it blocks untrusted apps from writing to protected directories. In terms of enforcing your security configuration, remember the Security Compliance Toolkit. It's a replacement for Security Compliance Manager on older versions of the operating system and allows you to analyze and configure systems against security baselines. Remember, I mentioned those at the start of the talk. I talked earlier about domain dominance. Another type of being pwned you want to avoid is virtualization dominance. That's where someone gets access to your virtualization administrator's accounts. Anybody who runs your virtualization infrastructure can export VMs and exfiltrate their contents. They can perform offline attacks against virtual machines. Basically, it's like they own the server, and if you own the server, you can take the hard disk out. Hyper-V provides you with the guarded fabric. Now, what a guarded fabric is it allows you to have guarded hosts which have specially recognized Hyper-V configurations and allows what's called a shielded VM to run. The configuration of that host is attested to, which means that it's a known configuration, not one that's been modified. If a virtualization host is untrusted, then a shielded VM will not boot. So what's a shielded VM? A shielded VM must use secure boot. It must use a virtual TPM. The VM state and live migration traffic is automatically encrypted. Data exchange and PowerShell Direct are disabled. Virtual machine connection is disabled. COM serial ports are disabled, and you cannot attach a debugger. What it means is your VM is completely shielded and protected from a rogue virtualization administrator. When hardening Windows Server, remember to implement Windows Defender Device Guard, or AppLocker is the old way of doing this. It's a hardware-based code integrity policies. Basically, if an application isn't on your whitelist and hasn't been pre-approved, it cannot run. It'll protect stuff at the kernel level. It'll protect stuff at the user mode level. It requires a TPM, secure boot, UEFI, and virtualization extension. Okay, to round out the session, I'm going to give you some advice about securing particular workloads. We'll start with securing AD. Use an enhanced security administration environment forest. I talked about that. Use read-only domain controllers in locations where your security is not assured. Run virtualized DCs as shielded VMs. Use Security Configuration Manager to apply configuration baselines. Use AppLocker and Device Guard to control execution of applications and scripts. DCs should basically run nothing except for out-of-the-box software. Limit your inbound RDP PowerShell connection to known privileged access workstations and jump servers. Block traffic from domain controllers to and from the internet. In terms of securing DNS, use DNS policies available in Server 2016 and 2019 to mediate how queries are handled on the basis of the characteristics of the DNS request. Configure DNSSEC and NRPT so that all the internal DNS records are digitally signed and authenticated. In terms of securing DHCP, configure MAC address filtering so that only known MAC addresses can request IP addresses. Configure secure dynamic DNS update settings so that only authorized hosts can actually update DNS records. In terms of securing your file servers, disable SMB1. Use File Server Resource Manager file screens to block the writing of unauthorized files types to file shares. If you want to protect the files themselves, use Azure RMS or Azure Information Protection, and then use Exploit Guard, controlled folder access to minimize the chance of a ransomware encryption writing data to sensitive file shares and folders. In terms of securing IIS, deploy IIS on a standalone server. Never deploy it on a DC. Install only the required modules. Don't install every IIS option. Run SQL and other servers on separate hosts. Move INETPub to a separate volume. Isolate your web applications using separate sites and application pools. And isolate ASP.NET temp folders. Where possible, start containerizing your applications. Shift applications over onto server core and nano server containers rather than running them by default directly on the IIS server. It's easier to blow away a container that's become corrupted than it is to blow away a server that has become corrupted. In terms of, and to finish with, here's some easy wins for you. Upgrade your domain controllers right now to Server 2016 or Server 2019 is much preferred now that it's gone GA. Disable NTLM in your domain. Implement privileged access workstations and limit where admin accounts can be used. Add admin accounts to protected users groups. Deploy your local administrator password solutions. Configure domain isolation policies. Deploy group managed service accounts. Place unsupported operating systems in air-gapped or isolated life support networks that are inaccessible to the internet. Thank you very much for your attention. If you've got any questions, please send me an email or contact me on Twitter. Thanks for your attention.